So electric field and the capacitor structure questions, question 12 we'll do, 12 onward. This is question 12. The photograph shows a path of an electron beam in a beam tube. There's an electron gun and there's an electron beam. You can see here, like this is an electron gun and this is a beam of electron and it is deflected here. The fine tube contains helium gas. It is at a very low pressure. When electrons strike the helium atom, the resulting excitation is responsible for a glow trace of a path. As you can see, there's a glow trace here. And the electron beam is emitted downward from an electron gun. So electron gun is emitting them downward. The electron gun contains a heating filament from an above an anode, and there's a potential of 135 volts between the anode and the filament, as you can see here. So 135 potential difference, 12 volt is there, which is supplied to this, and the potential difference between, so this potential 135 volt is used to accelerate the electrons. Describe how the beam is produced. Look, there are two ways we can produce the electron. One is called thermionic emission, another one is a photoelectric effect. What happens in a photoelectric effect? When the light falls on the metal, electron excited and they remove, if the energy of the incident wave is more than the work function, then electron gets excited and they are moving out from. Another one is a thermionic emission. In a thermionic emission, the electrons, like emission of electrons from a heated filament. So, and these electrons are accelerated by the electric field in a thermionic emission. So electrons are released by the heat energy. Which then accelerated by electric field. This is what happened in a thermionic emission. Show that the speed of electron leaving the electron gun is about 7 exponent 6 meter per second. So here we are using an electric field to accelerate. So electric field is used to accelerate. So the kinetic energy will be equals to electrical energy. So we can say the electrical energy is equals to kinetic energy. Electrical energy, voltage is work done per unit charge. So energy is voltage into charge. So voltage into charge is equals to half mv square. V is the voltage or the potential which we applied. That is 135. The charge of electron, it's a fixed value 1.6 into 10 to the power minus 19 coulombs. Half the mass of electron, you can use the constant value which will be given in exam. The rest mass of electron is 9.11 exponent minus 31 and multiply by V square. So then we simplify. So it will be 135 multiplied by 1.6 into 10 to the power minus 19 times 2 divided by 9.11 into 10 to the power minus 31. And this is V square, so we have to take a root to get the value of a V, which is about 6.89 into 10 to the power 6 meter per second, which is about 7 exponent 6 meter per second. So whenever electric field is used to accelerate the electron, then the electrical energy is equals to kinetic energy. In this question, the photograph shows an arrangement of investigating charge of a known as the shuttling ball. So this aluminum ball is there, two electrodes are there, and this ball will vibrate. A ball coated with a conductive metal, usually aluminum is used here, on a very long insulated thread. So this is insulated thread. The potential is applied across the plate so that X is positive and the Y is negative. When the ball touches against the plate Y, it gain a negative charge. So what actually happened when this ball touches Y, because this was negative, so now it will be negative. And then because like charges repel each other, so this will be repelled and it will be attracted towards the positive. When it reach here, all the negative charges will be removed and it will get a positive. And then again, like charges repel because X is positive, so then it will move other side. And this vibrate to and fro. So when the ball touches a plate X, the charge is transferred, the ball becomes positive and it will vibrate. Sketch the electric field between the plates on the diagram. So electric field lines, whenever we have two electrodes are there, the electric field lines, it's a constant electric field. So how we represent the constant electric field? So the spacing between the lines should be uniform, like equal spacing between the lines. That shows that we have a constant or a uniform electric field. The next is explain why the charge ball experience a horizontal force of a constant magnitude while it is between. So while there's a constant horizontal force is there, the reason is because the electric force E is equals to F over Q. So F is E into Q. Q is constant and E is electric field is also constant. So because there's a constant electric field, so if there's a constant electric field, that's why the force will also be constant. So there's a uniform electric field which has a constant electric field strength. That's why the force experienced by the charge sphere will be constant. The ball is initially at rest the ball is initially at rest touching plate Y. After it leaves plate Y, the ball accelerates from plate Y to plate X. The mass of a ball is 2.7 gram. Show that acceleration is about. So how we can show acceleration? We have the formula F is equals to ma. So if I want acceleration, F divided by m is equals to a. We have the mass of the ball, which is 2.7 gram, or we have to convert into kilograms. So 2.7 into 10 to the power minus 3 kilogram as we divide by 1000. So to get the acceleration, mass is already there. We need the force. How we can work out the force? So first, we'll work out the electric field. The electric field between the two plates, V is equals to ED, or E is equals to V divided by D. So voltage is there. The potential between the two plates is 5000 volts. And the spacing between the plates is 9.5 centimeter. We convert into meter. So 9.5 into 10 to the power minus 2. We divide by 100. This will give us the strength of the electric field between the plates, which is about 52,600 volts per meter, or you can also say Newton per coulomb. That's the unit of electric field strength. And then after getting the electric field strength, E is equals to F divided by Q. So if I need F, it will be E into Q, where E is the strength of electric field, which is 52,600, and Q is a charge. That is the total charge. It's given 11 nanocoulombs. So 11 into 10 to the power minus 9. When we multiply, we get the force, which is 5.79 into 10 to the power minus 4 Newton. That's a force. And after working out the force, you need an acceleration. So acceleration is force divided by mass. So the force which is experienced, that is 5.79 into 10 to the power minus 4. And the mass was 2.7 exponent minus 3. So we get the acceleration, which is about 0.2 meter per second square. So that's the acceleration of this metallic ball, which is in contact from one end to another. Question 14, which is about the fly zapper. Maybe you have seen this racket, which is used to kill insects, mosquitoes, especially. Two metal mesh. When a fly is between the mesh, the user presses the button and the potential of 1500 volts is applied between the mesh for a short time. And this potential causes the current in the fly and basically stunning it. A student thought that the racket must contain a capacitor. To investigate this, he connected a resistor with a high resistance between the mesh. So upper and the lower meshes are there, and he connect the resistor. The student press the button and use the data logger to record the potential. Because why data logger? Why not? Because whenever exponential is changes there, using a data logger, we can record many values in a short interval. So this is the graph which student got. Describe how the graph of potential against the time show that the racket contain a capacitor. You should not include any calculation. First, if there is a capacitor, because the charging and the discharging of a capacitor is exponential. So we don't have to show any calculation. We just mention, like, from this one, it shows that the change is exponential. The change of a voltage with reference to a time is exponential. And we can also work out, like, if we plot a graph between log of v, because whenever exponential changes are there, so if we plot a graph for log of v and t, then it must give a straight line. Because when a quantity is having an exponential change, if we plot for logarithm, we'll get a straight line that also shows that it has an exponential change. So what student could do, student can plot a graph between log against the log of v and time, and that will give a straight line. Shows that this change is exponential. Here, ln also you can plot ln as well. Natural log also you can plot a graph between L and V. That's fine. L and V and T. It should be a straight line with a negative gradient. That also is correct. So the simple idea, whenever you have a graph, exponential change graph is there, and you want to confirm whether this change is exponential, the simple way, just plot a graph for ln or log of that quantity with time. If it's a straight line with a negative gradient, it means it is exponential change. The next part, show that the capacitor has a capacitance of 10 nanofarad. Use the values from a graph, and resistance is 12 mega ohm. So we need the capacitance. So we can use a formula. We can use a formula V is equals to V naught e raised to power minus T over RC. V naught is a maximum value. Any value you can take. It's up to you. Even you can take the half-life time as well. That will also simplify your calculation. Or you can also use RC concept as well. So it won't make any difference. Like pair of a value we can have. So this value will be V naught. 10 boxes equals to 200, 5 boxes equals to 200. So each is representing 40. So this will be 1480 V naught. And at any time interval, so I'm taking 600, the new value, and the time interval is this. So we have this V, this will be V. So we have 600, we have V naught 1480 e raised to power minus t, which is in this case is 0.15. R is 12 mega, so it will be 12 into 10 to the power 6, and then C is there. Then 600 divided by 1480, this will be equals to e raised to power minus 0.15 divided by 12 exponent 6 times C. Then take ln both sides, because E is there, so take ln both sides. So ln 600 over 1480 and ln e raised to power minus 0.15 divided by 12 into 10 to the power 6 C. When you take ln and e, they cancel out each other. So ln of this value over 1480 is equals to minus 0. Because ln and e cancel. So it will be 12 into 10 to the power 6 times C. So if I need C, just I will get this value like fraction and then multiply by this whole numerator and C will be there. That will be the value of capacitance. That's how we solve the equation which include Ln. So if we have E, we cancel out using Ln. Ensure the safety of the human, the maximum allowed storage charge for a fly zapper is 45 microcoulomb. Show that this racket operates within the safe limits. So how we can show that it is within the maximum charge stored? So we have the formula Q is equals to CV is there. After working out the capacitance, here in this one, which is about 10 nanofarad, and the maximum voltage is 1500. So you can work out both ways. You can work out like using a formula Q is equals to CV. You can work out the maximum charge stored, or you can use the maximum charge in the capacitor, like how much is the voltage. Both ways it will work. So if I use a formula Q is equals to CV, and the maximum charge is stored on this, in this example, this is written like the maximum allowed charge is 45. But what charge is stored if we use our capacitance and the voltage? So here, if you use 10 nano, Q is equals to CV is there. So we'll, if it was 10 nano, like 10 into 10 to the power minus 9, and voltage, the operating voltage is there, which is 1500. So this will give us 1500 into 10 power minus 9. That will give us a maximum charge which we have in this case. So any value of a capacitor, I use it because I did not solve the previous part, but you will use this capacitance value for from your answer. Like say if it was 14 nano, so you will use 14 nano. 14 nano into 1500, and that will give us about 2.1 into 10 power minus 5 coulomb. So that is within the limit, because the maximum allowed charge is, or this one is 21 into 10 to the power minus 6 coulomb, which is 21 microcoulomb. So that is within the limit, because 45 is the maximum allowed, and this racket is only storing 21 microcoulombs. Calculate the energy stored when it's fully charged. So energy stored in the capacitor is half Q into V. So you have the maximum charge, and you have the energy stored on a fully charged capacitor. So when the capacitor is charged fully, the charge, what the maximum charge is there, we calculated that was 2.1 into 10 to the power minus 5, or 21 minus 6, and the voltage is 1500. So the maximum energy is 0.016 joules. That's the maximum energy this capacitor will store. The potential falls to about 5% of the initial value in less than half second. Explain why measuring with a data logger rather than a digital voltmeter and a timer. So why this is you have to write the advantage of a data logger. And so because data logger allow us to measure the simultaneous voltage and time, and large number of readings can be recorded in a short interval. That's the advantage of using a data logger over a stopwatch and any uh, digital watch we are using, or a timer or a meter, because we have to lot of, like, in a small interval we can record many values results. Question 15, an electron travels through a uniform electric field for 4.3 exponent minus 9 or 4.3 nanosecond, and it deviates from the original path. Calculate the deflection. So how to, and the direction of electric field is given because electron always move opposite to the direction of electric field. If electric field is in this way, electron will move other way because electric field direction is from positive to negative. How to do such question? If we need the direction of a deflection, this is like a projectile motion. It will have the two components. The vertical and the horizontal. Horizontal, there's no acceleration. Vertical motion, there's acceleration. First, we'll determine its acceleration, and then we'll determine the displacement, the vertical. So here initial speed, vertical speed is 0. Here it will have certain vertical speed and this displacement. So we'll consider like a projectile motion. If you remember AS, that a projectile motion, if it is falling, initial vertical velocity is always 0. And if we need the displacement, we determine the time. And we can use the equation S is equals to ut plus half at square. So S is equals to gt square we were using. But here it's not g, it will be at square. Because like equation of the motion, S is equals to ut plus half at square. So initial velocity is 0. So S is equals to 1 by 2 at square. So that S is actually the vertical displacement. How to work out the expression? F is equals to ma is there. So F divided by m is equals to a. How to work out the force? For this one, electric field strength is given. So E is equals to F over Q. So F is equals to E into Q. So E into Q will give us F. So in place of F, we can write EQ and divided by M. What is E? E is the strength of electric field. That is 1.3 into 10 to the power 4. Charge of electron, this is electron 1.6 into 10 to the power minus 19 coulomb. And the mass is 9.11 into 10 to the power minus 31 kg. This will give us the acceleration of this electron. And the acceleration is only in a vertical plane. Horizontal plane, there is no acceleration. So acceleration is 2.28 into 10 to the power 15 meter per second square. Now to work out the displacement, so S is equals to ut plus half at square. So S is equals to at square because u is 0. So we have half A is the acceleration, which is 2.28 into 10 to the power 15. And t square, the time, they give that it is taking 4.3 nanoseconds to cross this region of electric field. So then it will be square. And this will give us the vertical displacement, which is 0.021 meter. Sometime in the question, they give us the initial horizontal speed. Like say example, they say this electron was moving 3 into 10 to the power 6 meter per second. And they give us the distance in which it traveled. So using this speed and distance will determine the time. So we'll have the time, and acceleration will determine the same manner, and we'll also work out the vertical displacement. So this type of question in which the vertical displacement of electron we have to find, they are asking usually. So it's a common type of a question. So these are some questions from electric field. Any question or doubt related to this topic?